Hi, we're going to look at single, double, and triple bonds, Lewis structures. So I got the example is F2 and O2 and nitrogen for the triple bonds. Now, fluorine atom has 7 valence electrons. So we draw the 7 valence electrons for each fluorine atom, and second fluorine atom another 7 valence electrons. Now we connect one. Always you try with one and see whether you can complete the octet. We connect one. Now each fluorine has octet, so we are satisfied. So octet satisfied, single bond F2. And same thing, we can show that here. This shows the octet for this fluorine, and then the other fluorine will show the same thing. So one shared pair and then the rest of the lone pairs. So you can show single bond F2F and 3 lone pairs on each fluorine. So chlorine, bromine, iodine would show the same thing. So all halogens will show single bonds, single covalent bonds. Now look at oxygen. Each oxygen has 6 valence, and we show that, and we make a connection first, single bond, and then we see each oxygen has only 7 electrons. So that's not good. So we cancel that. We put another bond. Now we are trying to achieve octet. Now each oxygen has octet. So we can show that this oxygen has octet, double bond, and 2 lone pairs. This oxygen also has a double bond and 2 lone pairs. So both has octet complete. So we can show simply double bond O, 2 lone pairs nicely, and that's how you show the double bonds, right? Now, for the triple bond, we're going to take nitrogen. So each nitrogen has 5 valence electrons. We can show 5 valence electrons, 1 lone pair and 3 other unpaired electrons. Both nitrogen show the same thing. Now we add one bond and see whether you can satisfy the octet. So we connect one, we know there is no octet. We put another one, no octet, we put another one. So we put 3 bonds and nitrogen. Now each nitrogen has octet. We can show that 1 octet nitrogen, triple bond nitrogen, lone pair. So that's the triple bond. Now at the beginning of these videos, I told you exceptions will be shown. So electron deficient Bf3, and let's look at that one. Also we're going to talk about the SO3 for the hypervalency, and also PCl5 for the hypervalency. Only just few examples, right? Any other questions you can send in, so we'll try to do that. So boron has 3 electrons in the valence shell, and each fluorine will have 7 valence electrons, 1 connection, because fluorine gets the octet completed by doing that. So we satisfied the each fluorine single bond octet satisfied, but the poor center boron has no octet. So therefore that's an electron deficient. Same thing will be shown by aluminum chloride. So try to draw that and try to memorize that, right? So that's the electron deficient compounds, and boron and aluminum will show that. Now the other exception is SO3 minus, or sulfur and beyond, SO3 actually. So sulfur has 6 valence and each oxygen has 6 valence. We put them and connect one bond, and the oxygen has no octet. That's why we connect another one. So each oxygen has double bonds, and now the oxygens are happy, octet complete, but the sulfur is failing the pressure of total of 12 electrons. But sulfur can afford that. So that structure, Lewis structure, is correct. Now look at the PCl5. Phosphorus has 5 valence electrons. 5 chlorines are drawn in all sides, and then each chlorine has 7 electrons, right? We draw as possible way. All chlorine has 7 valence electrons, and then we need to connect each, right? So let's connect them. Here one bond here, single bond here, single bond there, single bond here. Now we have 5 single bonds for each 5 electrons of the phosphorus. So all good. So hypervalency looks like that. So center phosphorus has actually total of 10 electrons, and terminal chlorines have octet. So terminal oxygens have octet, but the central sulfur has 12 hypervalency. The hypervalency is due to the D shell, and that's the culprit behind, but we just need to know electron deficient and hypervalency examples. Any questions, send me in, and make sure in these ones, oxygen, nitrogen, and so on, they satisfy the octet. Thank you.